Alright, so in this video, we're going to go over two questions that I did not do initially when we were discussing geometric series. So we're going to go over these two questions. So question 16 says, a circle of radius 1 centimeter is drawn touching the three edges of an equilateral triangle. So this is an equilateral triangle. So we know that the sides are going to be the same and this angle is going to be 60 degrees. So that is something I want to keep in mind. Alright. Three smaller circles are then drawn at each corner to touch the original circle and two edges of the circle. So we have an incircle, right? This is your incircle with a radius of 1 centimeter. And then we have this circle. So this circle touches two edges and then one side of your main circle. And the smaller circle does the same. It touches one side of the medium circle and then two sides of the triangle, right? Two edges of the triangle and one side of the circle. And then this process is then repeated an infinite number of times. So you're going to have another circle here that looks like this and so on. All right. So we are asked to find the sum of the circumferences of all the circles. So we're going to do something here. What we are going to do is we're going to drop a perpendicular. And this is going to be 1 centimeter. And I am going to draw this edge temporarily for now. So one fact about this circle is that if I draw a line from a vertex passing through the center of my main circle to the midpoint of the other side, then this line where all the radii is going to lie, right? The radius of this circle lies here, right? This part is going to be the radius of the middle circle, the radius of the big circle lies. So all the radii lie on this line. So this line will bisect this angle exactly at half. So our initial angle was 60, so we are going to get 60 divided by 2 as our angle here. All right. So now that we know that, let's draw this line. All right. And remember, if you extend it, it has to connect to the midpoint, to the point of tangency on the other side. All right. And this angle is going to be 30 degrees. And what we are going to do is we are going to find this distance, which we will say is x for now. All right. So now we know that this distance is going to be 1 and that this is a right angle triangle because this baseline is tangent to the circle, right? All right. So we have everything here. So now what we are going to do is we are going to use basic trigonometry. So if I use sine of 30 degrees, this is going to be opposite, which is 1 over the hypotenuse. And the hypotenuse is this thing, which is 1 plus x. All right. So 1 over 2 is equal to 1 over 1 plus x. And then if you rearrange your terms, you get x is equal to 1. So an interesting thing that you notice is that the radius of the big circle is 1, and the distance from the edge of the big circle to the vertex is also 1, because x is equal to 1. All right. So now I'm going to erase some things. So I'm going to erase my triangle. All right, but I'm going to keep my x. So I know that this distance, which I previously called x, is equal to 1. All right, now what am I going to do? I'm going to repeat the process. I'm going to drop this here, right? And from the middle of this circle, sorry, I'm not going to drop a perpendicular here. I'm going to drop a perpendicular from the middle of the circle, just like I did for my big circle. All right. So I know that this whole thing has a length x. This is the radius of my medium circle, right? So I'm going to call the radius of my medium circle, this part, to be R1. All right. And this is, again, a 90-degree triangle. This angle is still going to be 30 degrees. So, and I know that this is also R1. Okay, because this is also the radius of the circle. So sine of 30 degrees, again, is going to be the opposite, which is R1, divided by the hypotenuse. Now, the hypotenuse is this highlighted section, right? This is R1, this is the angle, this is the hypotenuse. It's not exactly 1, because 1 is this whole thing. So it's going to be 1 minus R1. All right, so R1 divided by 1 minus R1. And sine 30 is half, so you have R1 divided by 1 minus R1. If you rearrange your terms, you send this here, you get this expression. So 3R1 is going to be equal to 1, and R1 is equal to 1 over 3. All right. So I know that the radius, so actually let me call this big circle to have a radius R1. So this just, let me say this was what we calculated was R2. All right, so R2, 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 2, 2, everywhere, right? So I know that, hey, R1, which is the radius of my big circle, is equal to 1. R2, which is the radius of my medium circle, is 1 over 3. And now let's repeat the process one last time for my small circle, right? And let's see the pattern. All right, so I'm going to erase the things here. I hope that is okay. So I know some things. Now I know that, hey, this medium circle right here, this medium circle has the radius R2. And R2 is 1 over 3. Now, one quick way to do things would be to notice the pattern. If this was 1, we figured out that this was 1 as well. So this being 1 over 3 makes this be 1 over 3 as well, right? Because remember, this part is also 1 over 3 because it's still the radius, right? So we have 2 over 3, and this part has to be 1 over 3 because total this is 1, right? So this distance is 1 over 3. All right. So now let's try to calculate this radii, and we are going to use the same method. We are going to use the same method, right? We know that, hey, we just discussed that this distance is also 1 over 3. So I'm going to erase this part. This distance is 1 over 3. I'm going to drop a perpendicular here. The angle here is still 30 degrees, right? This is a triangle. And basically what I need to do is, if I take the sine of 30 degrees, what is opposite? So opposite is this part. And what is this part? It's the radius of my small circle, which I will call R3. So it's R3 divided by, what am I dividing by? Well, I need to divide by the hypotenuse. Now, what is the hypotenuse? Well, it's 1 over 3, which is this whole thing, minus this part. And this part is just R3, right? So it's R3 divided by 1 over 3 minus R3. And sine 30 is half. So we have R3 divided by 1 over 3 minus R3. And now let's rearrange the terms. If I do so, I'm going to get this expression. And let's just solve this. So you get 3R3, if you send this to the other side, is 1 over 3. And R3 is going to be 1 over 9. So now we can figure out a pattern. We can see the pattern because this is going to continue to infinity, right? Ad infinitum. So the radius of the small circle is 1 over 9. All right, so R4, which is going to be a smaller circle, you multiply by 1 over 3, you multiply by 1 over 3, you multiply by 1 over 3, it has to be 1 over 27. And so on, right? So now let's find the sum of the circumferences of all the circle. All right, so let's solve for part A. So find the sum of the circumferences of all the circles, right? So let's look at the diagram. We have one big circle with the radius R1, right? So that is just going to be the circumference is just going to be 2 pi plus times R1. We have 3 circles with radius R2, right? If you remember, that is R2 is the radius of the medium circle. So you have 3, and then each medium circle has the circumference 2 pi R2. And then we have 3 small circles, right? With the radius R3. So we have 3 small circles, and each circle has the circumference 2 pi R3 because the circumference of a circle is 2 pi R. And this process is repeated ad infinitum. So let's continue this process up until R4. So you'll have 3 circles, right? And each circle will have a radius R4, and the circumference is going to be 2 pi R4. So on and on, right? All right, so 2 pi R1. Remember, R1 is just 1, right? So we have 2 pi plus 3 times 2 pi R2 is 1 over 3 plus 3 times 2 pi times R3 is just 1 over 9 plus 3 times 2 pi R4 is 1 over 27. All right, and we are going to continue this. So we have 2 pi here. The second term simplifies to 2 pi, plus the third term simplifies to 2 pi times 1 over 3, plus the fourth term simplifies to 2 pi, and then 3 times 1 over 27 is going to give you 1 over 9, and so on. So if you combine these two terms, you're going to get 4 pi. And then if you factor out 2 pi, from the next terms, you have 1 over 3 plus 1 over 9, and so on. And this continues to infinity. Right? This pattern continues to infinity. And now if you observe, this is a geometric series, right? It is a geometric series with a common ratio of 1 over 3. So now we're going to use the sum of a geometric series. So the sum of a geometric series tells me that, hey, if I'm adding to infinity and the common ratio, which is 1 over 3, right? If you find the common ratio, that you're going to get 1 over 3. If that is less than absolute value of 1, 1 over 3 is less than absolute value of 1, then the sum is a1, the first term, divided by 1 minus the common ratio. So if you simplify your denominator, you're going to get 2 over 3, right? And if you simplify this expression, you are going to get 1 over 2 to be your fraction. All right. So you're going to get 4 pi plus 2 pi times 1 over 2. And these two will cancel out. So you get 4 pi plus pi, which is equal to 5 pi. And that is your solution. So the sum of the circumferences of all the circles is going to be 5 pi. All right, let's solve for b. So find the sum of the areas of all the circles, right? So the area of circle 1 is going to be pi r1 squared. Then we have 3 circles with radius r2. So it's going to be 3 times pi r2 squared. Plus it's going to be 3 times pi r3 squared. And so on. So now, pi r1 squared is just 1 squared. So I'm just going to write it as pi. Right? From every other term, I can factor out 3 pi. So we have r2 squared plus r3 squared plus r4 squared and on and on. Alright, so let me just substitute in the values. r2 is 1 over 3. This is 1 over 3 squared, plus r3 is 1 over 9. So that is 1 over 9 squared. Plus r4 is 1 over 27. So this is 1 over 27 squared. And this goes on. Alright, so I have pi plus 3 pi. Now let's look at a pattern here. I think this is a geometric series. Why do I say that? Well, let me write the terms out. I have 1 over 3 squared, plus 1 over 9 squared, plus 1 over 27 squared, and so on. Well, if I divide these two, right, 1 over 9 squared, 1 over 9 squared. So let me just check, right? 1 over 9 squared divided by 1 over 3 squared. So I'm doing second term divided by first term is going to be 3 squared over 9 squared is going to be 3. Well, 3 squared is 9, right? 9 over 9 squared is going to be 1 over 9. All right. So the common ratio is 1 over 9. So I don't know if it's a geometric series yet, but I know that if you multiply your first term by 1 over 9, you get 1 over 9 squared. Let's do the same here. So if I do 1 over 27 squared divided by 1 over 9 squared, right, I will get something like 9 squared over 27 squared. All right. So I get 9 squared over 27 squared. And if I write this, 9 is just 3 squared, and 27 is just 3 cubed, squared. So 4 divided by 3, 6, right? 2 times 2 is 4, 3 times 2 is 6. All right. So now this gives me 1 over 3 squared, which is just 1 over 9 again. So this is also 1 over 9. All right, so this is indeed a geometric series. This is also going to form a geometric series with a common ratio of 1 over 9. So now you can just do pi plus 3 pi. 1 over 9 is less than 1, so this converges, right? So your solution is going to be 1 over 3 squared. The first term, the sum, is going to be 1 minus 1 over 9, right? If you use your formula, what is the formula? The sum of an infinite terms of a geometric series is a1 over 1 minus r. So we're going to use this. So first term is 1 over 3 squared, and my common ratio is 1 over 9, so I just use that. So 1 over 3 squared is just 1 over 9, and my denominator is going to give me 8 over 9. And 9s are going to cancel out, so my second fraction simplifies to 1 over 8. So my solution simplifies to pi plus 3 pi over 8, which is going to be 11 pi over 8 if you simplify everything. So that is your solution. 11 pi over 8 is the sum of the areas of all the circles. All right, so you have 11 pi over 8 as your final solution. So in this video, okay, I think this is going to be in the same video. So anyways, we're going to solve question 17. It's another question that I did not solve. So basically, we are constructing what is called a Gaussian snowflake. All right, so we start with an equilateral triangle, pattern 1, and we perform the following steps to produce pattern 2. So I'm not going to go over the steps, but what I'm going to do is, I know that, let's just call my pattern 1 having side S. So P1 refers to pattern 1, and pattern 1, sorry, so I'm going to do pattern 1, right? So basically, what is the area of the triangle? Well, P1, what is the perimeter? Well, P1 is simply 3S, right? It's this side plus this side plus this side. So it's 3S, right? And what is A1? What is the area of this triangle? Well, if you remember, so there are a lot of ways to do this, right? But basically, here's what we can do. This angle is going to be 60 degrees because it is equilateral. So this is going to be H, right? So let me draw that here. So I have this side is S, this side is H, this side, the bottom side is going to be, okay, we know the angle actually. So this is going to be 60 degrees, right? And the bottom side is going to be S over 2 because this is exactly going to be in the middle. So this is half of S, this is S, and this is H, and that is 60 degrees. So let me use some trigonometry. All right. So basically, let's say sine of 60 degrees is going to be opposite, which is H, over the hypotenuse, which is S. So S sine 60 degrees, so S times sine 60 degrees is going to be H. All right. So I don't need actually this side. So H is going to be S, and sine 60 is root 3 over 2. All right. So this height is S times root 3 over 2. So what is the area of this triangle? Well, it's going to be the half times base times height. All right, so what is the area? It's half. The base is S. What is the height? Well, the height we just found is S times root 3 over 2. So it's going to be half S squared times root 3 over 2. And we can rewrite this as root 3 over 4 S squared. All right, so it's root 3 over half times this times this is going to be root 3 over 4 times S squared. All right. And now for every other triangle, we're going to use this formula, right? Because everything else is also going to be an equilateral triangle. So we're just going to replace it with the corresponding side. And I'm going to explain what I mean by that. Okay, let's look at pattern 2. What is the perimeter of pattern 2? So the perimeter, to figure that out, well, we know that this side was previously S, right? It got divided into, if you read here, it's going to be divided into 3 equal segments. So this and this and this this is equal, and these are the 3 segments, right? So this side effectively is going to be our original divided by 3. Right? And now let's look at how many sides we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 sides. So our perimeter is just going to be 12 times S over 3, which is going to be 4S. All right. And now, let's look at A2. How do we find A2? Well, if you look at things, I already know this area. This area is just the area of my original triangle, right? So what is the area of my original triangle? It's root 3 over 4 S squared plus. Now I'm adding something. What am I adding? I'm adding the area of these 3 parts. Each part, right, because this is S3 and all of these are equilateral triangles, this part is S over 3, right? So the area of this triangle, sorry, let me highlight that in a different color, of this triangle with the side S3, this is an equilateral, this is angle 60 degrees. So if you repeat the process, or if you just use this formula, because it's going to work for every equilateral triangle, you're going to get root 3 over 4. And now what is the new side? Well, the new side is S over 3 squared, but how many triangles do we have like that? 1, 2, and 3, right? So we are going to have to multiply 3, and we are adding these two together, right? We're not subtracting, we are actually adding. All right, so now let's simplify this. So we have root 3 over 4s squared plus 3 root 3 over 4 times s squared over 9. And this is going to simplify to give me this, I think. Sorry. Yeah, it's going to simplify to give me root 3 over 4 s squared. So I'm just going to call this is the area of my original triangle, right? A1 plus this part is just going to be root 3 over 4 root 3 over 4 s squared times 1 over 3, right? We have root 3 over 4 from here, s squared from here, and then we have 1 over 3 here. All right, so I can write this as a1 plus root 3 over 4 s squared. What is it? It's the area of my original triangle, a1, right? So I'm going to say 1 over 3 a1. And that is just 4 over 3 a1, right? So if you simplify this, you're going to get this. So let's look at pattern 3 before we make any conclusions. Pattern 3. All right, so what is going to be S? What is going to be P3? Well, now, we know that this section, which was this, used to be S over 3, but that is again divided into 3 parts. So you have to divide this by 3 again. Okay, sorry, let me lock the image. All right, so ignore the illustrations here because we have everything we need. We know that from this second triangle, this used to be S over 3. So this part has to be S over 3. But if you want to find this part, that is going to be 3 equal segments again. So S over 3 divided by 3. And if you simplify that, you're going to get S over 9. And now let's just count how many sides that we have. All right. How many sides do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 30, 34, 35, 36, 37, 38, 39, 40, 41, 42, 40, 44, 45, 46, 47, 48, right? So we have 48 sides. So we have 48. So this P is going to be 48 times each side has a side length of 9, right? So if you think about it, we had 3 sides, right? And we had 3 sides in our original triangle. And in the second part, each side here got divided into 4 lengths. So 3 times 4. And then here, each side again gets divided into 4 lengths. So it's going to be this. So 4 4 is a 16, 16 3 is a 48. So that is why we have 48 sides there. So this is going to give you P3 is going to be, let's see. So our first length was 3s, our P2 was 4s. So this is going to simplify to something like 16 over 3s, I think. 48 over 9 is, 48 is 16 times 3 divided by 3 times 3. So yeah, 16 over 3. So we're going to get something like this. All right. So now let's look at the pattern. Let's figure out what Pn is. So if I have pattern n, right, before I go to the area. So for pattern n, we're going to figure it out using this, right? So how many sides are we going to have? We started with 3, right? We started with 3 sides. And for each step, so for triangle 2, we added 4 sides. So we're going to have 3 times 4. So, and it's going to have to be n minus 1. Why is it going to have to be n minus 1? Let's think about it. For pattern 1, n is going to be the pattern, right? So pattern 1, we had 3. So if it's just n here, then 4 times, so this is going to evaluate to 12. But we know that in our original triangle, we did not have 12 sides. We had only 3 sides. So it has to be n minus 1. So if you put 1 here, this simplifies to 1. So you only have 3 sides. If you put 2 here, you're going to simplify to, everything's going to simplify to 12, and you know that in your second triangle you had 12 sides, right? Now, how is our so this is the number of sides, right? Now, how is our side length gonna vary? Well, our side length is gonna be s over 3, right? And it's gonna be raised to n minus 1 as well. Why so? Well, if you remember, it's gonna be 1 over 3 and then you multiply by s. Why so? Well, if you think about it, in our initial triangle, we only had side length s, right? So our perimeter was, if you substitute 1 here, these will go away and you have perimeter 3s, which is what we had. If you substitute 2 here, right? If you substitute 2 here, then you're going to have, so 4 3s are 12, substitute 2 here, 12 over 3, you're going to get 4s, which is what you have here. So if you generalize the expression for Pn, you get this expression. All right, and this can be rewritten as 3s times 4 over 3 to the power n minus 1. All right, so for pattern n, we have the perimeter. And basically, it acts as to show that the pattern, the sequence tends to infinity. So let's show that. Well, for 1, P1 was 3s, P2 was 4s, P3, basically, what is the common ratio? And if you think about it, the common ratio is 4 over 3, right? Basically, 3s is getting multiplied by 4 over 3. So you have a geometric sequence and your common ratio. If you think about it, this is going to be your common ratio. And common ratio, which is 4 over 3, is bigger than modulus 1, right? It's bigger than modulus 1. It's bigger than 1. So therefore, this sequence diverges because the common ratio is bigger than 1. So that is why this pattern Pn diverges, right? It tends to infinity because when you look at each step, you're multiplying by 4 over 3, and 4 over 3 is bigger than 1, so it's not convergent. All right. So now, again, we have the story of 4 over 3 here, right? Your area 1 was A1. So for pattern 1, you had A1. For pattern 2, your area increased to 4 over 3. All right. So I hope that was clear. I hope why it diverges for A. All right. So now we are going to figure out part B, right? So we already discussed why the sequence tends to infinity. Now let's just figure out why the areas tend to 8 over 5 of the original area. So this triangle has the area A1, which we already know here, and we have already discussed the area of the first two triangles. Now I want you to look at some patterns here, right? How many sides does this triangle have? So this side, I'm going to call it S. This triangle has 3 sides. This triangle we already discussed has 12 sides. This triangle, so it goes with a geometric series, and we discussed this in a previous video as well. This had 48 sides, and this will have 48 times 4 sides, right? Because it's getting multiplied by 4. So the final pattern 4 will have 48.4 times 4. So 192 sides if you count every. So you go 1, 2, 3, 4. You're going to get 192 of them. All right. So now, this is the base pattern, right? So I'm going to say this is N0. Basically, our base, so we are asking how many new triangles do we have compared to the previous triangle, right? So there is no previous triangle, so we cannot have any new triangles. All right, how many new triangles do we have compared to the previous one? Well, the previous one was this. So how many new triangles do we have? 1, 2, and 3. All right. For this one, how many new triangles do we have compared to the previous one? So the previous one looks something like this. So how many new triangles do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 new triangles. And now, if you realize, this follows the same pattern, right? S3, N3, S12, N12. So for pattern 4, N is going to be 48. You are going to have 48 new triangles compared to the previous one. All right, now why does this matter? Well, if you think about it, what is A2? A2 is just A1 plus area of the new triangles, right? So it's just A1 plus the area of the new triangles. This was A1 is A1 plus area of new triangles, right? What is A3? Well, it's A1 plus A2 plus the area of the new triangles. Because this is A1, this is A2, plus it's all the area of the new triangles. All right, so let's write an expression for AN. So AN is going to be A1 plus A2 plus A3. We're going to go all the way up until AN minus 1, plus it's going to be area of the new triangles, right? But now let's start with A2. We know something, we can do something here. A2, right? So A1 had 3 sides. A2 had 12 sides. So how many new triangles did we have? We have 3 new triangles, right? So we have, for each step, A2, we had 3 new triangles. And now, each new triangle had the area. So I'm going to open this, right? We had 3 new triangles, and each new triangle is going to have the area. Now let's calculate the area of the new triangle. Well, we had 3 new triangles, and the side was S over 3, right? For this triangle, it was S over 3. For this triangle, it's S over 9. For this triangle, it's S over 27, and so on. So we had 3 times what is the area? So we're going to do that. So A1 plus A2 was just, we had 3 new triangles, right? So what is going to be the area of each new triangle? Well, it's going to be given by this expression that we discussed previously, right? So it's going to be, so let me calculate it here. It's going to be root 3 over 4. Instead of S, we have S over 3 because that is the side length squared, right? And I can rewrite this as root 3 over 4 S squared times 1 over 9. And this is going to be 1 over 9 A0, right? It's going to be 1 over 9 A0. So 3 times 1 over 9 A0. Plus, when we got to A3, how many new triangles did it have compared to the previous one? Well, it had 12 new triangles because we already had 12 new triangles, right? Now let's find the area of each triangle, right? So what is the area? It was 3 over 4, and each new triangle, so we're going to use this formula again. So it has to be root 3 over 4. Sorry, root 3 over 5, I already wrote that. What is the side? Well, each side was S over 9 this time, squared, right? And this is going to simplify to over 4 times S squared times 1 over 9 squared. All right, and this is 1 over 9 squared times A0. So we have 12 times 1 over 9 squared A0. And now I believe you can see the pattern. You can see the pattern here. All right, so this next term, we had 48 new triangles, right? If you remember, n was 48. And then we had 9 to the power 1, 9 to the power 2. So this has to be 9 cubed, A0. Plus, in the next step, how many new triangles? Well, it has to be 48 times 4, right? Because we were multiplying by 4, and then 1 over 9 to the power 4A0, and so on. We're going to continue on till n terms. All right. So A1 plus, and basically we extend this to infinity. So we're not stopping at n, we are extending this to infinity, right? So we consider the pattern up until infinity. So let's look at this. I'm going to keep the first thing as it is, but the second thing, I can write it as 3 times 4 over 3 squared. The third thing, I can write it as 3 times So I can write this as, sorry, the second term, 9 squared, right? So I have 1 over 9, 1 over 9 squared. The next term is going to be 3 times 4 over 9 to the power 3, right? And remember, we have, sorry, okay, let me rewrite everything. Because, okay, it's sort of difficult to figure out the pattern, but it's going to be 3 times, so we have this expression here, right? And then 12 is just, how did we get 12? Well, we had 3 sides, and then each side had 4 extra parts to it, right? Each side has 4 side lengths, so we multiplied by 4, so this is just 3 times 4 over 1 over 9 squared, a0. But this is just 3 times 4 times 4 times 1 over 9 cubed, a0, plus, and then we had 3 times 4 times 4 times 4, right? You're gonna get 48 times 4 this way, times 1 over 9 to the power 4, a0, and so on. So this continues up until infinity. So now, sorry, you can write this as a1. Everything is a1, my bad. a1, because we're writing in terms of the first area, right? So everything here is a1. All right. So now that we have this down, let me factor out a 1 over 9. And if I do so, I get 3a1 plus, from my second term, I'm going to get, and let me factor out a 3 from every term. So let me factor out a 3 over 9. So I can multiply 3 and factor out 3 over 9 from every term. So I get a1 from my first term. I'm going to get 4 over 9 from my second term. From my third term, I'm going to get 4 squared over 9 squared, a1. And now you can see we have formed a geometric series. And now I know how to get the sum here. What is the sum going to be? Well, the common ratio is 4 over 9. What is my first term? a1 divided by 1 minus 4 over 9, right? 1 minus r. So now I know, because we're continuing up until infinity, I can calculate this. So it's going to be a1 plus 3 over 9, which is just 1 over 3. Sorry, I'm going to write it as 3 over 9. You'll see why. And then from this term, you are going to get a1 times a1 divided by 5 over 9, right? And if you simplify, you are going to get 9 over 5, like this. So 9 here and 9 here cancels out, so you get a1 plus 3a1 over 5, and that is just 5a1. So if you simplify this, 5a1 over 5 plus 3a1 over 5 is just 8a1 over 5. So that is how you generalize this expression, and you get the answer, right? So it's 8 over 5 times a1, which is what the question asks to. So a1 was the area of the original triangle. And that is it. That is how you do the 2 questions that I did not do in the previous videos.